Hello there, everybody. My name is Ashley Hunt, Senior Project Management Instructor, and I want to talk to you about estimating durations. I look at it as kind of an art form rather than a science, but if you do want to apply a science to it, I can give you a really great formula to do so. So we're going to talk about how to facilitate the program evaluation and review technique for estimating durations, but it also can help you estimate costs as well. Same formulas. It just depends on what it is that you're using it for. So what's in it for you in this video? We're going to talk about what is PERT and why do you maybe need it for your projects, for estimations, and how to offer guidance to your team. As we go through this, I'll show you two different formulas. You might want to jot them down so you're able to use them on your own projects. But PERT stands for the Program Evaluation and Review Technique. It was created by the U.S. Navy when they were working on the Polaris missile project during the Cuban Missile Crisis. And so I always imagine three rocket scientists sitting around arguing about how long things should take. So you get the optimist who's like, we've got a great product and we've got great people and we've got support from senior management. Then you get the pessimist who says, I see risk everywhere. This could go sideways. That could go sideways. And then you have your expert who says, look, guys, I've done this a gazillion times. Here's how long it will take. The other formula that we'll take a look at basically is we've never done this before, but we have to accommodate risk on both sides, threats and opportunities, moving faster or moving more slowly due to a risk event. So that way, not only are we considering expert judgment, but we're also considering risk. So it allows us to come up with a better estimate based on actual time. Not ideal time, which is usually the optimistic estimate coming from a customer. Senior management, they're like, you should be able to do this in 3 weeks. And you're like, yeah, that's 4 months. What are you talking about? So this gives you the opportunity to really work with people who either overestimate or underestimate. People who do the work know the work, but this is an important discussion. We're not doing this in a vacuum. We want everybody involved to get what their thoughts are and estimates so that we can run a formula and say, all right, that's pretty close to the most likely estimate, plus or minus 2 or 3 days. Let's go ahead and add that contingency time to our schedule or contingency money to our budgets just to make sure. So it accommodates optimistic, pessimistic, and most likely estimates. There are two formulas. One is called beta distribution and one is called triangular. Whether you use one versus the other depends on whether or not your expert has done this particular activity before. And it can be on the project level as well. This is a similar project to one we've worked on before. So if that is the case, we're going to trust our expert judgment 4 times more than our optimist and our pessimist. And so the formula is optimistic plus 4 times the most likely plus pessimistic divided by 6. Why 6? It's a weighted average duration. There are 4 most likelies, 1 optimistic and 1 pessimistic. So in essence, when we trust expert judgment, we weight it more heavily. What if we've never done this before? Well, you're probably still going to have some experts running around who have opinions. But in this case, in triangular distribution, we're getting a true average. Optimistic plus most likely plus pessimistic divided by 3. There are 3 variables. It's a true average. So just think a triangle has 3 sides. If you've never done it before and you're just looking to accommodate risk equally with a most likely estimate, that is the formula that you want to use. So here's how this works. Let's say the team has done the activity numerous times. We've got great historical information, but we do know that a risk event could pop up. People on the team are like, well, this could happen. And somebody else might say, well, we might be able to move a little bit faster also if we have more people. How do we figure that out? So let's say the optimistic is 36 hours. The most likely is 44 hours, and the pessimistic is 60 hours. So in order to run the formula correctly, we're going to do the most likely first, 4 times the most likely, which in this case is 44, then equals, on the calculator, plus the optimistic plus the pessimistic equals divided by 6. That gives us 45.33. Now, most people looking at that would look at the most likely and say, 44, close enough, right? But what if this is weeks? What if it's months? Maybe almost 1.5 months passed? Even days can throw you off on a critical activity. So instead of just putting 44 in there, we're still accommodating risk a little bit, but at a lesser impact than, say, in the triangular distribution. For that, we're using the same variables, but we've never done this before. These are just estimates that people are throwing out. Usually the optimistic is the customer, the sponsor, and so on, and the pessimistic is somebody who's dealing with risk and all of that. So let's say we take 36 plus 44 plus 60, and we divide that by 3. That gives us 46.66. So that's 2. Actually, if you rounded it up, it would be 47. So that's 3 days, weeks, months past what our original estimate was. That allows us to manage risk. So how do you offer guidance to your team? Using a variety of different estimation techniques. You can use analogous or an analogy of past similar projects. You can use parametric, metric, math. That's how many resources are attached to durations, and everything gets added up and you get one big number. Or you can do a bottom-up estimate using your work breakdown structure, work package it all the way up, which is also what your software is doing, with other risk assessments. But when you're talking to your team, it's important to open up the conversation about risk. We're not doing it by ourselves as managers of projects or even agile project managers. Risk is everybody's job to identify and try and figure out the best responses. So final thoughts on utilizing PERT. Most customers, senior management, and so on, as you probably know, like that optimistic estimate. Then you have your experts who say, it's taken this long before, or we think it's going to take this long now. And then you also have your pessimist or risk that could be attached to certain activities. So discussing risk with your team on a regular basis can help you come up with more accurate estimates based on actual time rather than the ideal optimistic time. And I don't know what the deal is, but I actually use these formulas with my customers. For some reason, when you get out a calculator, and they're like, we think it should be 30 days. And you're like, ding, 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 ding. We think it should be 44. We're incorporating risk. And they're like, oh, it's math and a calculator. Must be right. So I don't know what the deal is with that, but it seems to work every single time. And either way, it gives us some negotiation, it gives us some discussion, and it allows us to take risk into consideration. So there you go, a practical application of math that you can use to estimate your durations or maybe even your money and get closer to a schedule that you can probably meet while working with your stakeholders and your team to try and get as close as possible to actual time, which, as we know, in most project management types of projects, we don't often get. Usually it's ideal time. So this is a good way to show your stakeholders what exactly it is that you're talking about when you add more time to your estimate. So hopefully that helps. Get out your calculator, talk to your stakeholders, and come up with a schedule that you can probably meet.